Well, I can tell you, years ago, if you had asked me, I would have said, well, I think we're years away from having something useful in terms of bot. And we all have this experience, trying a bot and say, oh gosh, that's not super useful. I must say that what was done, after GPT-3, which was another layer of learning that made it, very useful. And yeah, it's going to change the way we do search, but it's still a search engine and it's just an engine that does compute probabilities to find the next word, and it does a great job. And as shocking as it might sound, we haven't equipped the internet with the ability to learn. And you need to think very hard on what you're trying to achieve. I can tell you something, if you don't repeat it, of course, right?
Oh, no. Well, we're not filming, so don't worry.
Okay.
Hey everyone, David Bombal coming to you from Cisco Live again. Got a really exciting guest with me today. JP, welcome.
Thank you, David. I'm glad to be with you today as well.
Yeah, it's great. I mean, we were just talking offline, and then I stopped you. ChatGPT, it's going to take our jobs away.
No, I don't think so, David. I think that it's a tool.
Yep.
Right? And when you think about it, the technology is not that new, but what OpenAI managed to do is to make it very useful.
Yeah.
And for me, this is just a tool. It's true that the tool will be impacting. And it's exactly like, doctors with, like radiologists, for example, right? So they have new tools now.
Yeah.
They can do a better job. But is it going to replace doctors? No, I don't think so.
So, I mean, I've heard some people say, this is crazy, it's going to take all our jobs away. And then other people say, it's not that good. You were saying offline, you've got people in your team that are mathematicians and other people. So what did your team think about it? And what did you think about it?
Well, I can tell you, years ago, if you had asked me, I would have said, well, I think we're years away from having something useful in terms of bot. And we all have this experience, trying a bot and say, oh gosh, that's not super useful. I must say that what was done, after GPT-3, which was another layer of learning that made it, very useful. And yeah, it's going to change the way we do search, but it's still a search engine and it's just an engine that does compute probabilities to find the next word, and it does a great job. Now, when I hear people say, look, are they sentient? Of course not. They're not sentient in any way, but it doesn't mean that the tool is not useful. So yeah, the guys in my team were pretty impressed as well, as I was. But is it going to take our job? No way. We have a lot of stuff to do that machine can't do.
That's
sure.
great to hear. I mean, so it's not the Terminator. It's not going to kill us. It's not alive.
No, not at all.
And it's not going to take our jobs away, but it could be useful as part of our job.
Yeah, it could be useful. It's going to make our job even more interesting because we can focus on, what is more interesting as well. So I think this is just amazing, and we need to progress, and technology will never stop.
So you've been at Cisco a long time. You've done many things. You got to tell us patents. You've worked on BGP, MPLS, and then you're now working. Well, for the last few years, you'll have to give us the details. AI, machine learning with Cisco, right?
Yeah, absolutely. I joined Cisco, some time ago.
Yeah.
We don't want to think too much about this, but 25 years ago, to be more precise. I worked on MPLS, indeed, for many years with service providers. Then I led the IoT, which was a lot of fun. Then I moved to security and then Wi-Fi. And for the past decade, it has, I've been focusing with my team on machine learning, artificial intelligence. And some people may not know, but we've been working very hard on ML AI. And I think we have an amazing technology, and for many products, by the way. So I can tell you more if you want.
Yeah, I want to hear about it. So, I mean, because the concern for network engineers, I think, or a lot of people is, okay, my job's going to be taken away. You've said, no, that's very unlikely. But how's machine learning, how's what you're doing changing the way that we run networks or, operate networks, troubleshoot, et cetera, et cetera?
Yeah, I'm going to tell you something that might be a little bit shocking. You don't mind?
Yeah, no, go for it. The more shocking, the better.
Oh, really?
No,
okay.
Go for it.
But I'll tell you, I don't have a passion for technology.
Oh, wow. Okay, that is shocking.
Yeah. You know why? I have a passion for solving problems.
Yeah, okay.
And the technology is a side effect of it, if you will. So you're right that, I got a chance to have hundreds of patents, but my goal has never been to invent new technology. It has been to find the best technology to solve a problem. And I think that makes, my job absolutely exciting because I spend a lot of time with customers. I'm trying to find what will be the most interesting problem to solve in a few years with vision. And I'll tell you why ML and AI in a minute.
Yeah.
And that's how you come up with your technology. So the way it started, it has been an amazing journey. Almost 12 years when you think about it.
Wow.
And we started with the Internet of Things.
Yeah.
And at the time, we had to find optimal routing at the edge of a network, and we didn't have a chance to push all of the data in the cloud. You remember, at the time there was no cloud, pretty much.
We're old. Yeah.
Yeah. No, stop saying that, David.
Sorry.
No. But anyway, we had to do some local processing.
Yeah.
And machine learning was a very attractive technology at the time, very new for networking. So we started with that, and it was pretty amazing. We managed to do optimal routing. Then we worked on DDoS attack detection at the edge of a network. And when, security was top of mind, still top of mind for all of us. Yeah. And we started to say, hey, can we learn on-premise at the edge of a network and use machine learning to detect zero-day attacks? And it was a big success, and we made it a product. And so in 2016, we thought, okay, what's next? And we started to build the first cloud-based solution, ML/AI, and the first use case was wireless. So we started to anonymize the data, to run in the cloud, and we came up with a bunch of very interesting technologies to solve concrete problems. We managed to reduce the noise, to make it easy to troubleshoot. And we continued the journey, and then we worked on security again. For example, when you have an iPhone and you want to detect if there's a spoofing attack, for example, right? How do you do that? Well, we used to use static rules and thresholds, and of course, you can't do that at scale. So we started to train a model that will recognize the behavior using NetFlow, and it was again a success. In 2019, we started to work on predictive networks, which is the brand new product and technology we've been working on, but you have to tell me if you want to know more.
Yeah, no, of course. I mean, you said you were using NetFlow. So was it supervised learning, unsupervised learning? Just take us through the journey. Because the thing is, how does AI recognize this stuff?
Yeah, so it's actually fairly simple to explain. And you are a trainer, so you probably do a way better job than me.
I doubt that.
I think you do. But it's fairly simple to explain. So let's take a few use cases, right?
Yeah.
So the first one would be about Wi-Fi. So years ago, what we used to do was to send a bunch of telemetry data, and you would run with multiple rules and with static thresholds. And then you would just say, if X is greater than Y, then do this, right? That's how we used to manage Wi-Fi networks. It depends, right? It depends on the noise in the building, the quality of the signal, the number of users, right? So when you do that, you can continue to edit rules, at which point you start to stop scaling.
Yeah.
Or you can train a model and say to the model, your job is to learn what is normal versus abnormal. And you mentioned about supervised learning. It could be unsupervised learning as well. So for Wi-Fi, we started to predict, to compute what should be the normal throughput, for example, for users. Yeah. And that was done, fully automatically. Now, if you look at spoofing attack detection, the one that I was mentioning, you would just show multiple examples and say, this is the behavior of a camera, for example, right? So we take NetFlow. With a NetFlow record, you keep training and say, this is a camera, this is a camera, this is not a camera. And so the job...
you would tell it that, or it would figure it out?
Absolutely. Okay. Absolutely. So that would be supervised learning in this case, for example. And so you would keep training, and so at some point, the classifier would look at the behavior of any device that claims to be a camera.
Okay.
And if the classifier says, well, it's unlikely to be the behavior of a camera, that might be a spoofing attack. So that's one example. The next one was even more interesting. So I can't resist to tell you more about predictive. You're ready?
Yeah, go for it. Go for it.
You sure?
Of course.
You have a lot of
That's
time,
why you're here. That's why you're here.
Okay, great. So predictive. So predictive was that we are in 2019. And so when you look at the internet, as much as you and I love the internet, it has been reactive for 35 years. Yeah. So upon detecting a link failure, it would take minutes 20 years ago, and then seconds, and then milliseconds with MPLS fast reroute, IP fast reroute, and stuff like that. But you still react. And as shocking as it might sound, we haven't equipped the internet with the ability to learn.
That's true. Yeah.
And so we thought, well, we've been developing products in ML/AI for almost a decade. Is that a way to start learning so that we can predict issues? And if we can predict issues, guess what? You can avoid issues and you can increase the SLA. So I'm sure you're going to ask me the question, which is...
go for it. If you're going to preempt it, predictive networks, here we go.
Yeah, but... And so when we started, a lot of skepticism around us.
Yeah, I can imagine,
A lot of resistance as well.
Of course.
Which is always a good sign when you're trying to innovate, right? If there's no resistance, you're not disrupting. One of the mistakes we did years ago, and I strongly believe in the ability to learn when you make mistakes, that's how the human brain works, right? Was to jump on the model.
Jump on the model.
Yeah. So you would just take a ton of data, and the first thing you would do is to train a machine learning model and jump on it and refine the model and stuff like that.
I see what you're saying, like train it.
Absolutely. And of course, you don't want to do that. The first thing you need to do is to look at the telemetry, the raw data, and do a little bit more of data science as opposed to machine learning modeling, if you will, and try to see if there's a little bit of a signal in the data that may be used by a model to indeed predict. And so we spent about 1 year looking at, I think it was 2,000 service providers, millions of paths across the internet, and say, can we find some signal that will allow us to predict issues before they happen? You may say, David, hey, can you predict a power outage? And the answer is, I wish I could. I would be very rich.
You would be.
Oh, yeah, for sure.
Yeah.
Or fiber cut. And, well, no, it's very difficult. Why? Because, well, we don't have, first of all, when you train a model, you need to have a lot of data. And there are not so many fiber cuts. And so it's very difficult to predict rare events. So in our case, the sort of issues you can predict is, and we all experience this kind of issue. You take the road at 6 p.m. on the highway, there will be a bottleneck. So this kind of seasonal effect. But that's not the only thing that we can predict. So the idea was to say, if I take a massive amount of data, can I start predicting some SLA violation, for example, so that if I have a high accuracy when I predict, then I can start avoiding this kind of issues, if you will. So we're not predicting fiber cut, no power outage. Still, we can predict a fairly big chunk of issues before they happen. And if for the things we cannot predict, we fall back to reactive. That's the story.
When you said you didn't want to jump on the AI, was that because we as humans, especially engineers perhaps, we want to grab control and try and, because we know better, or we think we know better, you just had to let it learn. Is that right?
Yes. I'll tell you why. Because it's not very hard to do a prototype. It's actually fairly simple. Now you can use a bunch of libraries, TensorFlow and scikit-learn and all these things. And so taking some data and jumping on the modeling is very easy to do. But it's a mistake, because if you do that without looking at the telemetry first, without even thinking of the model, but just look at the telemetry, you will find out, first of all, that most of your time will be spent on the quality of the data, which is the measure issue. We spend about 70% of our time only on the telemetry.
Yeah.
And you want to remove the noise and all the things. And you need to think very hard on what you're trying to achieve. I can tell you something, if you don't repeat it, of course, right?
Oh, no. Well, we're not filming, so don't worry.
Okay. All right, so I'll tell you that. One of the biggest challenge, and that's a question I've got all the time, is are you guys coming up with your own algorithm? And say, of course, sometimes we do that. And so then people say, so it's not very hard to do, right? You're just using some libraries and you just, right? Auto-learning, it's called. And I'm like, well, not quite. So first of all...
It's only, you've been working on it for 10 years.
Yeah, exactly.
Just pull in some Python libraries.
Exactly right. And so what are the main challenges? Well, the first one is look at the telemetry. And I keep repeating that. Sorry about that. But so if you guys start in the machine learning AI field, look at data science, quality of telemetry, because if you have a poor quality of data in the first place, people talk all the time about the volume of data. The more data, the better, which is not always true, by the way. It's often true, but not always. But you look at the quality of the telemetry. And you know what is the second trap? This is the metric that you're trying to optimize.
Okay.
Because
it's like a threshold, right?
Well, the objective metric, the performance metric, for example.
Like, is there a problem or isn't there a problem?
How do you assess the efficacy of your algorithm?
Yeah. Okay.
And that's very hard, because with many algorithms, you're not coming up with one metric, but 10.
Yeah.
And you never know which one to really optimize. Well, you do know when you have some expertise in the field. If you want to do ML/AI for the networking industry, don't think that you can give a telemetry to a data scientist or machine learning engineer and say, go and just optimize the model. You need to have deep expertise in networking, first of all.
Yeah.
So our job are not going away.
Yeah.
One. And second, you need to understand the metric you're trying to optimize. And that's the most difficult task. Is it a business metric? Is it a performance metric? For example, if you take some algorithm that are doing prediction, for example, are you trying to optimize what we call the log entropy, or are you trying to optimize the performance? The percentage of issues you can catch. If you're doing false positive, is it an issue? Is it an issue to do false negative?
Yep.
And I can give you many examples. Look at healthcare. In healthcare, they don't want to do false negative.
Yeah.
And when you work in security, you hate false positive because at some point you don't even pay attention to. So
exactly.
it depends how you tune your model and what you're trying to achieve. So I could go on and on about these problems, but this is very important.
No, but it's good. I mean, I think the two things I want to ask you is, number one, when do we see this in Cisco products, and what products are those? And then number two, if I'm interested as a network engineer, like this sounds like this is something I need to start learning now. How do I become like you, or like what's the roadmap to, like, what should I study? So
thank you very much for the second question, because I'm as passionate as you are about training people. I think this is so important. So, but let's talk about Cisco first, if you don't mind, real quick. This has been in production for a long time.
Okay.
So if you look at Cisco AI network analytics for Wi-Fi, we have thousands of customers in production at a very large scale. If you look at Cisco endpoint analytics, Cisco AI endpoint analytics, the name is so long, it took me 2 years to remember it. But we have millions of devices being monitored. If you look at predictive, guess what? We had Cisco Live 2023. We announced it this afternoon. So we have two products. One is called One Insight from Thousand Eyes. So that was an internal innovation at Cisco, predictive networks. And we have two products using it. One is Thousand Eyes, the acquisition we've made a few years ago, which is awesome, by the way. When you do internal innovation and you use it for a company that we acquired years ago, it's a great feeling. And the second one is SD-WAN Viptela vAnalytics. And we're launching two products next month in GA. Now, let's go back to the other question about how do you start. I think the best answer is watch your YouTube, by the way.
Oh, thanks.
It's a good way to start, right?
Thanks.
Isn't it?
Yep.
But seriously, I do mean it. You have really good videos there. Then I would go to Coursera. Which is always a great start. Andrew Eng, he did many things like that. Udemy, many excellent courses over there. And when you think about it, I don't want to look like a grandpa, but look at that. 20 years ago, you had to buy books everywhere, right? Now you have a ton of information on YouTube, and that's the best way to start. But there's a little bit of a trap, which is that don't be stuck with books and things like that. You need to have hands-on. You need to try. There are many data sets now available, publicly available, that you can play with. And in a matter of a few hours, you can easily have an account and you start to play with Scikit-learn or whatever. And you need to try and experiment. Now, that's the best way to start, I believe, and be hands-on, and then join a team like our team. That's the best way to learn. Because the scale is the issue, by the way. It's not,
it's like you said, prototype's easy.
Yeah, prototype is very easy. And you can do that in a matter of a few days. If you are passionate about it, it's very easy to do. When you think about scale with millions of devices, as we do at Cisco, it's a bit more complicated, and you need to join a team that has been doing that for a long time.
What skills do you need? Is it like Python? Do you need to know pandas? Or is it just like jump in and just play?
No, Python is one of the best, if not the best language. There are other languages, of course, but yes, you're right. You need to know PyTorch and, all the pandas is a great one. Spark, if you want to go at scale and do parallel computing, these sort of things. So absolutely you need that. Don't forget networking.
Because I wanted to, the problem, I saw this when sorry to interrupt, when we moved from like traditional CLI, like configuring devices, and then we went to like automation. The problem I always found was, there was a lot of Python training on stuff that wasn't networking. So the problem is like, how do I learn AI in a networking context? Any suggestions? That's
a very good question. It's I think that you need to do both in parallel. I don't think there's any workaround. There are a lot of great specialization like CCNA and up to CCIE.
So do like normal networking, but then do also separate track like learn AI.
Absolutely. And apply your knowledge, networking knowledge, and use ML AI to do that. start with an interesting use case. And I keep saying that. I'm sorry and there are many, many use cases. I think we're just scratching the surface. I told you about, security. Security has been using ML AI for a long time.
Yeah.
Collab.
Yeah.
You are using ML AI, but networking as well. So I mentioned Wi-Fi, LAN switching, WAN. I was mentioning about predictive. So there are many, many use cases. And I think it's fairly simple to take some data set and with NetFlow, look at NetFlow, right? We have many example logs, and you start to apply it to very simple use case. Don't start with something too difficult. Another advice that I would take is if you do follow the ML AI, research, these guys will tend to jump from one thing to another.
Yeah. Yeah.
And so the risk is to take the most sexy and latest algorithm. Don't do that. I mean, start with simple stuff like trees, decision trees. You can do amazing stuff with decision trees, ensemble techniques and GBT and all these things. And if you want to do a little bit of deep learning, do that, but don't start with the latest and greatest transformers, for example, and go incrementally.
The problem is, I might know networking. Like learning Python for a lot of guys is really tough.
Yeah, it is.
And now this is like just another step of feels like craziness that I have to learn. Is it really difficult?
No. Let me tell you why. Because of course, if you want to become a core ML engineer, you need to have a deep background on statistics, obviously.
I was going to say maths. Yeah.
But as a practitioner, you don't need to know that. Backprop, for example. If you want to go into all of the details of backprop, you need to know a little bit what a derivative is and how to compute these things. But why would you need to know what is under the cover?
Yeah.
You don't need that. You need to understand a bit how it works and how to interpret the results and keep your networking expertise, and you'll go very far.
So do you see, because some people have been saying this, like, as a network engineer in the old days, we used to have to try and memorize everything, perhaps. But then you start using Google. It's like, don't try and memorize everything.
Yeah.
Just use Google. Know how to use Google. Do you think it'll go the same way? People are talking about we'll become AI engineers. Like we'll use AI more and more to help with our jobs.
I think we will. Does that mean that we're going to have to remember less? I don't think so.
Okay.
I think we won't have to remember non-interesting stuff.
Yeah, so that's the difference. Rather than doing all the mundane stuff, we're going to do like the clever stuff, if you like.
I think so. And I think that our scope is going to be a bit broader.
Yeah.
So instead of being pure networking, it's going to be a mix between networking, programmation, as you said, Python, these sort of things, and a little bit of machine learning AI. But, again, for me, ML AI is a tool. It's nothing more than a tool, but a very useful tool.
So if I'm 18, and I always use that as an example, but let's say I'm maybe older, but I want to transition into this, CCNA, and maybe DevNet, like DevNet Associate.
Absolutely. That's a very good path. On the side, you do a little bit of programmation.
Andrew's course on Coursera.
Yeah, or Udemy or whatever. Some other courses, and you try to be very much hands-on. If you are interested in the math, well, why not? I mean, if you want to understand what deeper, you can do that. My son is 17. He's at EPFL, just starting his educational path, if you will, at EPFL. And I keep saying, look, it's good. You love math. That's great. But you need to be a little bit hands-on. I'm trying still to convince him to do a networking career, but I'm not there yet. Maybe he heard too much of internet, in his life. But yeah, it's a combination. I think this is very important to not be on just one technology. But you know what, David? You've been in that field for a long time as well. If you want to have a broad scope, would you be stuck with one area like Wi-Fi? No. But exactly the same thing. So you would do some networking, and in addition to that, Python, you need to know more about the cloud. It's unavoidable, especially with machine learning. You can do on-prem, but there are so many tools that you can use. Why not using these tools? And on the side, you start doing some training on ML AI. But my fear is always that some people, when they start with ML AI, they think, oh, it's not for me. There's too much math and stuff like that.
Exactly, because you get confused with the maths. But it's the same with programming, because you might get like...
Exactly.
Programming is not for network people, but it's a different type of programming.
That's exactly right. Yeah. You're absolutely spot on. And again, you don't need to know what is really deep inside of the algorithmic side. The one thing that I would say is look at statistics.
Okay.
Because there are many people, we go for an interview and we give them some basic stuff to do, like a percentile, and they say percentile. And say,
Yeah.
Okay. So basic stuff, it's not rocket science, but at least, you need to know a little bit about statistical tests and stuff like that, but it's not rocket science. So this still, I'm super optimistic about the future. Seriously, I'm very optimistic because it has never been so easy, seriously, to learn new stuff. And I think that we can go even further in networking by using these kind of tools.
Is it too late for someone to get into this? If I'm a bit older, or has the industry already moved on?
Not at all, David. I think this is quite the opposite. And you can be 40, 50, or 60 years old. If you are curious and you want to deep dive, years ago it was the case. Years ago we did not have really the tools, and you had to understand deeply the mechanics and all these things. Now there are many tools. As long as you understand that and I think this is very important for our career as well, to have a broad scope, and it's no longer about a specific technology, but if you have all of your knowledge about networking, and you have some programming skills, and you don't need to know so much in there, but still a bit of programming, you understand a bit the statistics, there are many tools that will help you. And I think we have a bright future. I think that's going to be even more exciting than the past 20 years. So I'm very, very optimistic.
JP, thanks so much for sharing, and thanks for the encouraging words, because it's like people are worried. So thanks for sharing.
Yeah, we should not. I think we should be excited instead of being worried, and I really mean it.
Brilliant.
Thank you,
Thanks,
David.
JP. Cheers.
Thank you. Cheers.